Moving forward in space, China has just sent Queqiao 2 to the moon. This satellite, launched in March 2024, is more than a simple exploration tool. It's a crucial step in China's big plan to create a permanent moon presence in the next 10 years. Let's explore what this means for the future. Lunar exploration and the moon's tidal locking. For a long time, the moon's period of rotation and revolution have been in perfect sync, a phenomenon called tidal lock. This causes the same side of the moon to always face the Earth. Historically, all lunar missions have taken place on this visible side, as it was the only area we could reliably communicate with using ground stations. However, this is about to change. Major space nations, including China and the US with its partners, are shifting their focus beyond the familiar side of the moon. They are now looking toward the far side, which has remained relatively unexplored until now. Even more exciting is the interest in the lunar South Pole, where permanently shadowed craters are believed to hold water in the form of ice. This discovery could have major implications for future space exploration and potential human settlement. To support missions in these remote areas, relay satellites are being developed to maintain communication links. The exploration of these new lunar territories marks a significant step in deepening our understanding of the moon and its resources, opening up new opportunities for science, discovery, and perhaps even life beyond Earth. Queqiao 1 and Queqiao 2 relay missions. In order to communicate effectively with spacecraft on the moon's far side, relay satellites are crucial. These satellites are strategically placed to provide connectivity between lunar missions and Earth-based ground stations. China first demonstrated this capability in 2018 with the launch of the Chang'e 4 mission, which included a relay satellite positioned in a halo orbit around the Earth-Moon L2 Lagrange point. This satellite helped facilitate the Chang'e 4 lander and rover's operations on the far side of the moon. At the time, this was groundbreaking because while relay satellites were not a new concept, their use around the moon was. On March 20th, 2024, China achieved another milestone by launching the Tianwen-2 relay satellite, an advanced successor to the earlier model. This 1.2-ton spacecraft entered an elliptical orbit around the moon, specifically designed to support the upcoming Chang'e 6 sample return mission. Set to launch in May 2024, this mission aims to collect samples from the South Pole Aitken Basin on the moon's far side. The Tianwen-2 will also assist future Chang'e missions, including Chang'e 7 and Chang'e 8, planned for 2026 and 2028, which will also target the lunar South Pole. The Tianwen-2's orbit is meticulously designed to optimize its support capabilities. It has a highly elliptical trajectory with its farthest point, or apogee, reaching 16,000 kilometers from the moon and its closest point, or perigee, coming within 200 kilometers. This orbit ensures that the satellite spends most of its time at apogee, where it is positioned to provide continuous visibility to missions on the lunar surface. Additionally, the apogee is aligned to face the lunar South Pole, ensuring that the Tianwen-2 remains in communication with Chang'e 6 for over 20 hours each day, effectively relaying signals to Earth. This enhanced capability marks a significant advancement in lunar exploration and communication technology, initiating the Queqiao Lunar Network. The Queqiao 2 mission is part of China's larger vision to establish a permanent presence on the moon by the 2030s, known as the International Lunar Research Station, ILRS. This ambitious project aims to create a fully operational lunar base, which will rely heavily on advanced communication, navigation, and remote sensing technologies. Although still in the planning stages, the ILRS represents a significant leap in China's lunar exploration goals. In pursuit of this vision, China has developed a comprehensive lunar communication infrastructure plan called the Constellation. This plan is being implemented in 3 phases. The first phase, Queqiao 1.0, includes the initial Queqiao satellite launched in 2018, which is still active. The second phase features the recently launched Queqiao 2, which continues to support China's lunar missions. The final phase, Queqiao 3.0, is expected to deploy by the end of the decade. These satellites are individual missions but also serve as building blocks for a larger system. For instance, the Queqiao 2 mission included 2 smaller satellites, Tiandu 1 and Tiandu 2, weighing 61 kg and 15 kg respectively. These satellites were placed into an elliptical lunar orbit with the goal of testing radio and laser ranging technologies. Their primary purpose is to lay the groundwork for future lunar navigation services, akin to a lunar GPS system. The next step in the Queqiao Constellation project, Queqiao 2.0, is planned for the 2030. This phase will involve deploying a constellation of 16 satellites around the moon. The constellation will include 7 satellites positioned at the Earth-Moon L1, L2, and L3 points, 2 satellites in an elliptical orbit, 6 in low lunar orbit, and 1 in geostationary orbit. This network aims to provide high-speed communication with Earth, ranging from 1 to 10 gigabits per second, and to achieve positioning accuracy on the lunar surface within 50 meters, along with some remote sensing capabilities. Looking further ahead, Queqiao 3.0 envisions an even more advanced network that integrates lunar, Martian, and Earth-based relay systems. This future network, anticipated for the 2040 or 2050, aims to enhance interplanetary communication and coordination, marking a major step forward in space exploration. This ambitious vision highlights China's commitment to establishing a robust presence in space and pushing the boundaries of lunar and interplanetary research. Similar projects by NASA and ESA. The exploration of advanced lunar technologies isn't limited to China. Across the Pacific, NASA introduced the LunaNet concept in 2019, aiming to create a network of interoperable lunar and Earth-based systems with the help of international partners. To support this vision, NASA launched the Lunar Communications Relay and Navigation Systems project in 2022. Similarly, the European Space Agency began the Moonlight project. As lunar missions increase over the next decade, such communication infrastructures will be essential. Expect to hear more about these developments in the future. For updates on China's advancements in this area, keep an eye on their ongoing projects and missions. That's all for this video.